Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 8 learners. Welcome to the Natural Science lesson. My name is Tawegile Tebem, and this program is proudly brought to you by the Houghton Department of Education. Our topic today, grade 8, is visible light. And what are we going to focus on? Our subtopic is radiation of light and spectrum of visible light. Radiation of light and spectrum of visible light. First of all, let's look at our objectives. That's our goal today. We want to achieve something. What are we going to achieve by the end of this lesson? We are going to explain that light is emitted from luminous objects. And we're going to explain that light travels in straight lines, grade 8. And we are going to state that white light can form a spectrum consisting of colors of different frequencies and wavelengths. And then we're also going to explain what happens when light is dispersed by a prism. Okay. And then we're also going to explain how a rainbow is formed. Grade 8. Interesting, isn't it? And we get all this from the CAPS document, page 50. Let's look at our pre-knowledge. The pre-knowledge is what we have already covered in the previous years that is related to this topic. What have you done? That's our foundation that is already there. In grade 7, we did the transfer of energy, focusing on the solar energy. All right. And then let's remind ourselves of what we have done in this topic. That is our baseline activity. Let's do the baseline activity. I'll just give you a minute to answer those two questions. Are you done writing the activity, grade 8? That's very good. Let's look at the questions together. Question number 1 says, what is the source of natural light on Earth? And question number 2 is, why is photosynthesis important? You still remember, don't you? All right. If you've got a question or there's something that you don't understand, grade 8, remember to send us a text on our WhatsApp number 064 748 8913. Our number again, 064 748 8913. Okay, let's look at our answers. For question number 1, the source of natural light on Earth is the what? Is the sun. The sun is the ultimate source of light on Earth. And then let's look at question number 2. Our answer is photosynthesis is important. Why is photosynthesis important? Remember when we did photosynthesis grade 8 last term. It is important because it converts solar energy into what? Into chemical energy. All right. And store chemical energy for future use. Remember, the plants are the producers. Therefore, they must have this energy. All right. Remember, the plants need the energy from the sun. They also need what? They need water from the soil. They also need what? They also need carbon dioxide from the atmosphere, so that it will give us what? Sugars and oxygen. Okay. It's very important. All right. Did you get it correct, grade 8? Congratulations, that's very good. If you didn't get it correct, no problem. You're going to get it correct the next time. Just listen to the lesson so that you will understand. Okay, let's move on, grade 8. let's look at our terminology. Remember, in each and every lesson, we come across new words. We need to define some words in order for us to understand better. So pay particular attention, grade 8, so that you'll understand better. Let's look at the first term, radiation. What does the word radiation mean? Radiation, this is the energy that is emitted by what? By electromagnetic waves. All right. And then let's look at the next term. We've got luminous. What do you think luminous mean? If we're talking about a luminous object, we're talking about an object that is emitting light, that is giving off light. For example, what is luminous in our classroom? If you switch on the light bulbs, what's going to happen? They are going to glow. They are emitting light. They are luminous. And remember, the sun is luminous. All right. Why am I saying the sun is luminous? Because it is emitting light. It gives off light. You get that, grade 8? That's good. Let's look at the next one, which is illuminated. When we are looking at an illuminated object, this object does not give light. For example, a moon, it does not give light, but it reflects light from the sun. All right? Illuminated, an object that provides light by reflecting light. For example, the moon, it reflects light from the sun. Do you get that? That's very good. Let's continue with our terminology. We've got visible light. What is visible light? What does it mean? These are the electromagnetic waves that can produce a what? A visual sensation. And then the next one is wavelength. When we are talking about the wavelength, remember when we are talking about light, we're going to be talking about wavelengths, different waves. Okay. And then when we're talking about the wavelength, we're talking about the distance in between the crests or the distance in between the throws. All right. We're going to come across a lot of diagrams. You'll understand better. All right. And then frequency. When we're looking at frequency, we are looking at the number of waves that pass at a certain point at a given time. That is frequency. All right. That's why when we are switching on a radio, we put a times at 94.5. Those are the frequencies. Okay. The number of waves that pass a certain point every second. That is our frequency. And then spectrum. What are we talking about when we are saying spectrum, grade 8? This is a band of what? It's a band of colors. All right. This is a band of colors produced by separating of components of light by their different degrees of refraction. It brings us another word, a new word, refraction. What does the word refraction mean? When we're talking about refraction, it is when white light hits, for example, a glass prism, and then when it bends, we call that refraction. All right. The white light hits a glass prism, then it bends. That is refraction. And then it splits and gives us what? The colors of the rainbow. All right. Interesting, isn't it? And then another word, we've got refraction. Refraction, this is the bending of the wave when it passes from one medium to another of a different optical density. That is refraction. Remember, refraction, it is when light is bending. All right. And then we are talking about passing through different mediums. When we're saying passing through different mediums, we mean that light can pass through a glass. It can pass through water. That is medium. Okay. And then we've got a photo there. You can see the light coming in. All right. This is a forest and you can see light. And you can see light is what? Is diverging. Look at this. This is a cone shape. All right. It is diverging. Okay. That is the power of light. We are seeing white light. But if we had showers or if we had water droplets or rain, what were we going to see? We're going to see a rainbow. Why am I saying we're going to see a rainbow? It is because when white light strikes a droplet of water, it splits, and then we can see a rainbow. All right, white light is a band that has got a lot of colors in it. Once it hits a glass prism or even a water droplet, that's when it produces a rainbow. You get that? Interesting, grade 8. And then let's look at radiation of light. Light can come from different sources. And then objects that give off light, we call them luminous. You see, luminous is coming in now. All the objects that give off light or emit light, they are luminous. Okay. And then objects that do not give off light, we call them illuminated objects. These don't give off light. They don't emit light. They are illuminated. It's different between the difference between luminous and illuminated. Luminous is an object that gives off light. For example, we've got the sun. We've got our light bulbs that are glowing. They are giving off light. A switched on torch, it gives off light. Even fire, it gives off light. Therefore, it's luminous. But we've got objects that don't give off light. For example, we've got the moon. It doesn't emit light, but it reflects light from the sun. You get it? That's very good, grade 8. The light energy from luminous object is transferred by radiation. Light is a form of energy known as electromagnetic radiation. All right. The sun is the primary source of light. You get that, grade 8? The sun is the primary source of light. And then other luminous objects are, for example, we've got light bulbs, we've got burning candles, we've got the fire. Those are the examples of what? Of luminous objects. And then let's continue with radiation of light. This type of energy travels through space. If it travels through space, it means it travels through a vacuum, and it travels very fast when it is traveling through space. Okay. All right. This type of energy travels through space, which is a vacuum, as it does not need particles to be transmitted. And then light travels extremely fast, right? Especially in a vacuum. It travels for approximately 300,000 kilometers per second. You see how fast it travels? A second, you can just say a second has lapsed. But light travels approximately 300 kilometers within a second. You can see how fast it travels when it is traveling through a vacuum. You get that? That's very good. The sun is about 150 million kilometers from the earth. That's very far, isn't it? But look at the sun. It is giving us light. It is also giving us heat, but it is far away. It is about 150 million kilometers from the earth, and it is luminous. Why are we saying it is luminous? It is giving off light. It is emitting light. All right, good. The moon is an illuminated object. We only see it because it reflects light from the sun. That's why we see the moon. All right, it is illuminated. It does not emit light, but it reflects light from the sun. You get that? That's very good, grade 8. We can only see the things because light shines on them. That's when we can see things. All right. And then light energy is radiated from luminous objects. Now you know what a luminous object is. Remember, we said a luminous object is the one that emits light. It gives off light. You get that? When light is radiated from a source such as a light bulb or a torch or a beam of light is visible, and then light travels in straight lines. Light travels in straight lines. Okay. And then the beam is only visible when particles such as dust or water droplets scatter the light. That is why a car headlights show up well in the mist. You can see a picture of a car and you can see the headlights. They show up well in a mist. And then we've got a beam of light here. This is a light source, and you can see light is diverging and forming a what? A cone shape. It is diverging, showing what? Producing a cone shape. All right, light energy is radiated from luminous objects. Light energy is radiated from luminous objects. Beams of light diverge from their source, forming a what? A cone shape. When we say they diverge, they will be diverging like this from the source. They diverge, forming a what? A cone shape, grade 8. This phenomenon is easily seen in a what? Car headlights, a lighthouse, spotlights, or even torch beams. You can see this. All right. The further the light travels, the less beams diverge. All right. We can only see this when we are near, but when it travels further, then the less it appears. All right. Light from distant object is taken to be traveling in parallel rays. What are we meaning when we say parallel? Parallel, it will be side by side. That is parallel. Okay. However, in close objects, light is still divergent. For example, we've got a lighthouse here. You can see this picture, grade 8. This is a lighthouse. And then why are we saying light is divergent? This is the source. Here, this is the source of light. And you can see light diverging and forming a what? It is forming a cone shape. Okay. That's how it is traveling. And then we've got a pinhole camera. A pinhole camera is a basic type of a camera that shows how light rays behave or how light travels in a straight line. Okay. A pinhole camera is used to form a what? An upside down image of a luminous object on a screen. Okay. The pinhole camera can be constructed using a shoebox that is painted black inside. And then the viewing hole is made with a what? With a pin. And at the other end, the side of the shoebox is removed and fitted with what? With wax or even tissue paper as a screen. Okay. The pinhole acts as a what? A camera. Okay. And then you put a what? A screen so that the image will be shown. And then you let light pass, but you are the one who's going to control the whole of the camera. You can maneuver it and make it small or make it large, depending on what you want, all right? Depending on how much light you want to enter, okay? And then light enters the tiny hole and forms an image on the screen or even on the tissue paper at the back of the camera. The amount of light that gets into the camera can be controlled by changing the size of the what? Of the hole in front of the camera. You can see a tree here, and then this is a pinhole, all right? You can control how much light enters the camera, and then you'll see an image. We are seeing an upside down image. You can see a tree, then on the other side on the screen you can see a what? An upside down image. That is a mirror image. It is inverted. You get that? And this proceed grade 8. And then when light passes through the pinhole, an inverted image of the object being viewed will be formed on the screen. That is a tissue paper that we have put. And then the light rays also cross from left to right. They cross from left to right. Okay. So the image is mirrored as well as inverted. When it is upside down, it will be mirrored or inverted. Okay. And then we've got an activity, grade 8, which I want us to work on now. I'm going to give you 2 minutes to write the activity. Question number 1 says, Give the meaning of the following terms. A, luminous. B, radiation. And then question number 2 says, from the table below, list the object that you can see in the dark. From the below pictures, list the objects you cannot see in the dark. Then B, you can see in the dark. You're going to list those. All right, I'm giving you 2 minutes. All right, grade 8, you are done writing your activity. You can shoot your activity and send us on WhatsApp. Our number is 064 748 8913. Our number again, 064 748 8913. We would love to see your work. All right, let's go through the questions together, grade 9. Give the meaning of the following terms. A, luminous. What does the word luminous mean, grade 8? When we are talking about luminous, we are talking about an object that is emitting light, an object that is giving off light. For example, the sun is luminous. It is emitting light. It is giving off light. Even our bulbs in our classroom, if you switch them on, they will glow. They are emitting light. Do you get that? And then we've got radiation. Radiation, these are the electromagnetic waves. All right? Remember, we get the radiation energy from the sun. Okay. And then let's go to question number 2. From the below pictures, list the objects A, you cannot see in the dark. We've got different pictures there. Some of the pictures you can see in the dark and some of them you cannot see in the dark. Let's check our pictures before we answer the questions. We've got burning candles. We've got clothes. For example, your uniforms. We also have fire. We also have a wooden table. We've got glowing bulbs. We also have books. Which pictures can you see in the dark? And which pictures can you not see in the dark? Those that you cannot see in the dark. Let's start with those that you cannot see in the dark. For example, we've got your uniforms or your clothes. But remember, there are some clothes that you can see in the dark. For example, the reflectors that the bikers put on. Those you can see in the dark. All right? But our uniforms, we cannot see in the dark. And then we've got a coffee table, a wooden one. You cannot see in the dark. Just imagine a dark room without lights. And then if you enter there, you cannot see the table. You just bump on it. Okay. And then we've got books. The books you cannot see in the dark. Just imagine a very dark room at night without lights. Can you see books? You cannot see books. Okay. And then what about burning candles? You can see burning candles in the dark. And what about fire? You can see the fire in the dark. Why? Because it is luminous. It is emitting light. What about the bulbs? Can you see bulbs in the dark? Yes, you can see glowing bulbs in the dark. All right. And then spectrum of visible light. When we are looking at the spectrum of the visible light, the sun radiates white light. Okay, it radiates white light. And then white light is a combination of all different colors of light. It is a combination of all different colors of light. When we see white light, we'll just see white light. But once it strikes a glass prism, we can see the light, white light splitting, producing different colors of the rainbow. Even if they are droplets of rain, you can see the rainbow. Why? It is because white light strikes that droplet and then it will reflect the light. Remember refraction. Okay? We said the light will bend. Okay? And then it will split, producing the colors of the rainbow. Do you get that? That's very good, grade 8. And then the collection of all the colors that you can find in a rainbow is called a what? A spectrum of visible light. That is a band of colors. And then light is also called a what? A wave. Why? Because it travels. Okay. It is a wave because it travels and it moves in a regular, repetitive pattern. Okay. But you cannot see the pattern that light creates. Okay. And then we've got different colors producing different patterns. They've got different wavelengths. Remember what we said about a wavelength. If we're talking about a wavelength, we are talking about a distance from a crest. This is a crest, grade 8. The top part is called a what? A crest. Okay, this is the top part. And then the bottom part, we call it a what? We call it a throw. All right. And then when we are talking about the wavelength, we are talking about the distance from one crest to the other. For example, from this crest going to this crest, this is the wavelength. Wavelength. All right. And you can see the wavelengths are different. All right. For red is longer, followed by orange, followed by yellow, green, and then the shortest one is the violet, indigo, and blue. You can see the wavelength. All right. This is interesting. And then the spectrum of visible light. Each color of visible light has a what? Has a characteristic wave. Some colors have long waves and others short waves. Remember we said red has got the what? The longest wavelength. And then violet has got the shortest wavelength. Okay. Wavelength is the length of one wave pattern. If we're talking about one wave pattern, for example here, this is a crest, this is a crest, and the distance in between these is called a what? A wavelength. Even with a throw. This is a throw. The distance from here to here, we call it a what? A wavelength. Okay. And then wavelength is the length of one wave pattern. It is the distance between the consecutive crest or throws in a wave. It is measured between 2 points that are in a phase. Okay. And then wavelength is measured from one crest of the wave to the next crest of the wave. or even from one throw to the next throw. Okay, and then please note that short wavelengths are measured in units called what? Nanometer. They are very small. Okay, they are measured in nanometer. The shorter the wavelength, the more waves are able to pass at a certain point at a given time. All right, if the wavelength is short, there are many waves which are going to pass at a certain point. For example, if we take violet, we are going to have a high frequency. Why am I saying high frequency? It is because there will be a number of waves that pass at a certain point at a given time. Compared to red, red has got the longest wavelength. Therefore, if we compare the violet and the red has got the lowest frequency, but the highest what? Wavelength. And then the violet has got the shortest wavelength, but the highest frequency. Okay, why? Because of the number of waves that will pass at a certain point at a given time. Do you get that? All right, let's move on. And then the shorter the wavelength, the more waves will be able to pass at a certain point at a given time, and the greater the energy. Interesting, isn't it? All right, let's look at this one. These are the wavelengths for the violet. And then this side, the wavelength of the what? Of the red. You can see the wavelength is long. And then the wavelength here is very short. But the violet has got the highest frequency because there will be a number of waves that will pass at a certain point at a given time compared to red, because red has got the longest wavelength. All right. And then there are 7 colors. All right. If we're looking at the spectrum of visible light, it has got the 7 colors. These are the colors of the rainbow. Okay. And then we've got red, orange, yellow, green, blue, indigo, and violet. All right. You can just call them Roy G. Biv to make it simple for you and interesting. If we say Roy G. Biv, this is red, orange, yellow, green, blue, indigo, and violet. This is interesting. Okay. Each of these colors have a what? A different frequency and wavelength. And these colors are easily remembered if you use what? Roy G. Biv. All right. And then the 3 colors, red, green, and blue, are called the primary colors of light. And then these are different from primary colors of paint. They are different. Remember here, the primary colors of light, we have said it is what? Red, green, and blue. They are different from the primary colors of what? From the primary colors of paint. And the primary colors of light, when combined together, they give us white light. Do you get that, grade 8? That's very good. If the 3 primary colors of light are mixed, they form what? White light, grade 8. Okay. And then dispersion of white light. The speed of light changes slightly depending on the medium through which it travels. Remember, light travels very fast in a vacuum, in an empty space. But the speed varies if it is passing different types of medium. For example, if it passes through water, even if it passes through glass, the speed will change. Okay. And then it is faster when traveling through space, but slower when traveling through an optically denser medium such as glass or water. When white light strikes the side of a glass prism, it goes from an optically less dense medium to an optically more dense medium. A prism is a block of glass or even perspex that can split white light. All right, what are we meaning here? If we've got white light and then it strikes a glass prism, what's going to happen? It is going to split and produce what? And produce different colors of the rainbow. It will bend. Remember refraction. We said light refracts. Okay. When it hits a glass prism, it bends. That is, it refracts. And then it will disperse, producing what? Different colors of the rainbow. Even in nature, it does that. How does it do it? If we've got a raindrop, then the white light will strike a raindrop, then it will refract, producing what? Different colors of the rainbow. That's why we see the rainbow in the sky. And if you notice, the colors of the rainbow, the natural one, they will be blending, all right? It's unlike the one that is hitting a glass prism here. You can see the picture, this one here. These colors are shown brightly so that you can see the colors of the rainbow. But in nature, you will see that the colors are blending. All right? Let's carry on. This is because light rays slow down and bend, a phenomenon called refraction. Okay? It refracts, it bends in a way. And then dispersion of white light. The sides of the triangular prism are angled. The light rays strike the object at an angle. And then the color of light we see depends on its wavelength and frequency. This is very important. Frequency is the number of waves that pass at a certain point each second. All right. That is what? Frequency. Okay. And then red and orange light have the longest wavelength. Why are you saying they've got the longest wavelength? If you check on red, you can see the distance in between the crests. It is long. And then this is red here. And then orange is following red this side. And it is blending. You can see these colors. They are the colors of the rainbow. Okay. They are blending into each other. And then the red and the orange have got longer wavelength compared to other colors. For example, violet and indigo, they've got the shortest wavelength. Therefore, if they have the shortest wavelength, they've got a high frequency. Why am I saying high frequency? It is because of the number of waves that will pass at a certain point at a given time. Okay, this is interesting. All right, let's continue. Different light waves are all refracted at different angles, which spread them out. This phenomenon is called dispersion. It is always easy to distinguish all the colors of the spectrum. All right, we've got different diagrams here which show a clear distinction between one color and the next. But in reality, colors blend. All right, this diagram will show you different colors, and we've named them red, orange, yellow, green, blue, indigo, and violet. But let's look at them in reality, in nature. The colors are blending. All right. It's not like in this diagram, but here the colors are blending. These are the colors of the rainbow. Interesting, isn't it? And then a rainbow forms after a storm because tiny droplets of water in the atmosphere act like a what? Act like a glass prism. And then the water droplets disperse the light from the sun and reflects it towards the direction of the light. This makes it possible to see the what? The rainbow only if the sun is behind you. You can see a rainbow here. This is an interesting picture. Can you see the rainbow and the colors? And look closely at the colors. They are blending. All right. There are no distinct lines, but they are blending to the other colors. Okay. And then we've got activity 2, grade 8, which we are going to answer. Let's check the activity together. When are you able to see a rainbow? When are you able to see a rainbow? Then question number 2. What is meant by the dispersion of light? What is meant by the dispersion of light? And then 3. White light consists of a range of different frequencies and wavelengths. A. Give an example from nature that shows how white light can be separated with different frequencies and wavelengths. And then 3B. Name the different colors that make up the spectrum of visible light. All right, grade 8. I'll give you 5 minutes to answer those questions. Hope you are done answering the questions, grade 8. Let's look at the questions together. Question number 1 says, when are you able to see a rainbow? Remember, you see a rainbow when there is white light and water droplets. Why are we saying so? Because white light is going to strike a water droplet, and then there will be splitting of light. All right, and then you can see a rainbow because white light is a band of different colors. Once it splits, then it shows different colors of the rainbow. And then what is meant by the dispersion of light? What do we mean when we say the dispersion of light? When white light strikes a glass prism or even a water droplet, what happens? A light refracts, it bends, and then it disperses. It shows different colors of the rainbow. And then white light consists of a range of different frequencies and wavelengths. A, give an example from nature that shows how white light can be separated into different frequencies and wavelengths. We are supposed to give an example from nature. This is a rainbow, grade 8. Okay. And then B, name the different colors that make up the spectrum of visible light. All right, we are going to write Roy, Jim, Beef. All right, what am I saying? Roy, G, Beef. R is standing for red, O for orange, then yellow, then green, then blue, and then indigo, and finally violet. All right, these are different colors that make up the spectrum of visible light. Okay, who got it all correct? Congratulations, that's very good. And those that didn't get it correct, don't worry, you will understand and you'll get it correct the next time. All right, let's carry on with our lesson, grade 8. All right, let's look at our summary. Light is emitted by luminous objects. What are we meaning if we say light is emitted by luminous objects? Light is given off by luminous objects. And what are the luminous objects, grade 8? The luminous objects are those that emit light, are those objects that give off light. Okay, for example, the sun is the ultimate source of light. All right, and then in our classrooms, if we switch on the lights now, they will glow. Those are luminous. Why are we saying they are luminous? Because they are giving off light. They are emitting light, grade 8. Even fire, if you make fire, it is luminous. Why? It is giving off light. You can even see it in the dark. All right. And then even a torch. If you switch on your torch is also luminous. Why? Because it is giving off light. Now we know the meaning of luminous, grade 8. Okay. And then light travels in straight lines. Light will always travel in a straight line. If it hits a glass prism, it will refract. Okay, it will bend. Do you get it? If it hits a what? A drop of water, it will also refract. Okay. And then light travels very fast through empty space. It travels extremely fast at a empty space that is in a vacuum. That's why we said it can even travel about 300,000 kilometers per second. That's extremely fast. You can see that, grade 8. And then white light is made up of a range of waves with different wavelengths and different frequencies. What are we meaning if we are saying different wavelengths? Remember, there are some colors like red. They've got a longer wavelength. All right. For example, if I may draw the wavelength of red, you can see from this crest up to this crest, if you draw a line here, this is the distance. Okay. Then the wavelength is long. But for some colors like indigo and violet, the wavelength is short. Okay. And then what does it mean when it comes to frequency? Remember, we defined frequency as the number of waves that pass at a certain point at a given time. And then if you compare red and violet, you will see that violet has got the highest frequency than red. Why? Because it has got a short wavelength. And then a lot of waves will pass from point A to point B at a given time. And then if you compare with red, and then a few waves will pass at exactly the same distance and same time. All right? Therefore, it has the lowest frequency and violet has the highest frequency. But the violet has got a shorter wavelength and red has got a longer wavelength. Interesting. And then let's check the next one. The 7 colors that make up white light are, we've got red, orange, yellow, green, blue, indigo, and violet. All right. Remember, we talked about Roy G. Biv. All right. Roy G. Biv will make you remember Roy G. Biv. It will make you remember these colors. It's easy to memorize it like that way. R stands for red, orange, yellow, green, blue, indigo, and violet, grade 8. All right. Don't forget these. They are the 7 colors. They are the colors of the rainbow. Okay. They are the colors that make up white light. All right. And then we've got violet. Violet has the shortest wavelength. Remember what we said about violet. The wavelength is very short. Okay. It has got the shortest wavelength. Okay. And then the highest frequency. If we say the shortest wavelength, the distance between the crest or the distance between the throws is very short. And then the frequency, we are counting the number of the waves. Okay. We are counting the number of the waves that pass at a certain point at a given time. All right. And red has the longest wavelength and lowest frequency. Longest wavelength, it will appear like this. All right. And then we are talking about the distance in between the throws. Okay. This is the wavelength. It is longer than the one for the violet. And then the frequency is very low because there are a few number of waves that will pass at a certain point at a given time compared to violet. All right. And then a rainbow forms when light falls on water droplets in the air. That's why we see a rainbow. Okay. Why is it forming when light falls on water droplets in the air? It is going to split, all right? Remember we said light travel in straight lines, okay? And then once it hits a droplet of water, it will refract, that is, it will burn, and then it will disperse, forming the colors of the rainbow, okay? Interesting, grade 8. This is the rainbow. You can see the colors, but the colors are not just distinct, they are blending on each other. All right, you can see the blend of colors that's making it wonderful and beautiful. All right, grade 8, we've got a homework. Therefore, I'll just give you 2 minutes to quickly copy the homework. Hope you are done copying the questions, grade 8. Let's go through the questions quickly and make sure you write the homework on your own and bring it to class. What is the difference between a luminous object and an illuminated object? Then question number 2, give the correct sequence in which the colors of the rainbow appear, starting with the color that has the highest frequency to the color with the lowest frequency. Why do rainbows normally form when it is cloudy and not on a bright sunny day? And the last one says, which color will have the shortest wavelength? Make sure you answer those questions at home. And then now we are going to WhatsApp. We want to check your questions, grade 8. Let's go to WhatsApp. And then we want to check your questions that you have asked. Okay. And then let's check your question. All right. Question number 1 says, what is the meaning of luminous? When we are talking about luminous, these are the objects that are giving off light. All right. For example, the sun is luminous. It is giving off light. And the sun is the what? Is the source of light on earth. Do you get that, grade 8? Let's check if you've got some questions. Okay. All right. It seems we no longer have questions. Let's go back to our lesson, grade 8. Remember, when we are talking about luminous, we are talking about those objects that emit what? That emit light. For example, the objects that are luminous, we've got the bulbs in our classroom. They are luminous. And even fire is luminous. Okay. And then now we are going to look at the brief preview of the next lesson. In our next lesson, we're going to explain opaque and transparent substances, grade 8. All right. Thank you very much, grade 8. But remember to go to the complete slide, and then you press complete after the end of this lesson, so that it will show that you have completed the lesson with me. All right. That's very good. Thank you very much. See you next time. But remember to always sanitize or wash your hands with soap, maintain social distance, and always wear a mask. Be kind to yourself and start grade 8. So long for now.